Okay, this is Core Pure 1, Edexcel, June 2019. Very first question on the paper. It's a little complex numbers question. Starts off quite straightforward. You are told you have this function, this polynomial, which is simply given this. So none of the coefficients been given. C, Z and D. There we go. But you're told two of the roots. So you're told two of the solutions to f of z being equal to 0. And the roots you're given are -1 plus 2i and 3 minus I. So first thing, a nice starter for 4 marks, show all the roots of f of z equals 0 on a single Argand diagram. So if these are your roots that you know, then because they're complex roots, the complex conjugate will also be a root. So here we're going to have -1 minus 2i, and here we're going to have 3 plus I as our two solutions to the other roots. So there's our 4 roots, and we have to show them on an Argand diagram, so that's pretty straightforward. We just literally go, right, so get it just roughly right, it's just a sketch, and I always like to do little arrows going out to it. So 3 plus I is going to be something like that over there. 3 minus I is going to be a reflection down here, because obviously it's going to go out to the same area. It doesn't matter if it's not a perfect reflection, they won't penalise you for things like that. -1 plus 2i up there. Oops, yeah, let's give it a bit more slant, shall we? Up there, and then -1 minus 2i down there. Boom. 4 marks. Nice and simple. Okay, so we've got they leading us nicely into the paper here, doing something like that. They then, as you would expect, they want to know what A, B, C and D is. So, a couple of ways in which we can approach this. Let me just get the rubber down here. Oh. So, the easiest way, I think, is to realise, obviously, this being a quartic can be, and no coefficient in front of the Z4, we could basically have this kind of situation where our 4 roots, alpha, beta, gamma and delta. That basically f of z can factorise to that. And our alpha, beta, gamma and delta are these 4 roots. So we could just put these 4 roots in there and start doing some multiplying out. Okay? However, let's be a bit sensible about that. Because our roots are conjugate pairs, we can group them together to make 2 quadratics. I think this is slightly quicker way in which you go, right, okay, well, let's have alpha and beta being this conjugate pair, -1 plus 2i and -1 minus 2i. And using roots of polynomials, I'll work on roots of polynomials, we know that if we've got a polynomial, is with the alpha and beta as our roots, it's going to be this basically. The 2 roots add together to give us the number of the coefficient from the z, but the negative of that, and the 2 roots multiply together to give us the coefficient at the end. Okay, the constant term at the end. So probably it's easier to get our 2 quadratics, the quadratic using these 2 roots, the quadratic using these 2 roots, and then multiply our quadratics together. Now it becomes nice and easy because they're conjugate pairs. They're nice and easy to add. They're also nice and easy to multiply. So we're going to use this roots of polynomials to get our 2 quadratics quickly. So if we add those 2 together, obviously the i's are going to cancel, positive 2i and minus 2i. So it's just going to be -2. So we know it's going to be z squared minus -2, so that's plus 2z. And then alpha, beta, these 2 multiply together. Well, we know what happens here in this situation. We've got a plus and a minus making a minus, but then I times I making I squared. which we know is -1. So this is going to turn into a plus altogether. So really the quick way of doing it is just going, right, -1 times -1 is 1, 2 times 2 is 4, add them together, got 5. So there's our quadratic for these two roots. And we're just going to do the same for these two roots, conjugate pairs. So add them together, 3 and 3, 6. So it's going to be z squared minus 6z. And then multiply them together, 3 times 3 is 9, 1 times 1 is 1. Add together, make 10. Bingo. Okay? And then all we have to do now, we've got two quadratics that we could just multiply together. So let's do a bit of that quickly. So we're going to get z to the 4 minus 6z cubed. So each term obviously multiplied through 10z squared and so on. So we're going to get 2z cubed minus 12z squared. I'm going to run out of room. Plus 20z. Can I squeeze it in on the end here? No, I'm not going to. I'll go down here. So 5z squared minus 30z and then plus 50. Sorted out, z to the 4, cube terms, we've got minus 6, so minus 4z cubed. Z squared terms, 10 minus 12, so minus 2, plus 5 there is plus 3z squared. Z terms, 20 minus 30 minus 10z. And then we've got good old 50 on the end there. All done. Okay, so our A is minus 4, our B is 3, our C is minus 10, and our D is 50. Now this approach, getting into two quadratics, you could say, well, why don't I just go to use roots of polynomials to go the whole hog with a quartic? But it's much more messy because you're going to have your 4 roots added together to make your z cubed, but then you're going to have your pairs to get b, and you've got lots of combinations of pairs. Same with triples. It becomes a bit messy, a bit too much work. So it's much easier to break it down into quadratics, 2 quadratics, and then boom, multiply it out. Okay, there we go.